Good day, my angels. Here is a solution key to the Lesson 1 Ohm's Law homework. Again, the key ideas is inside a battery or a cell, a chemical reaction is going on where charges are separated. Work is done in separating the charges, kind of like work is done in lifting an object higher. And so, kind of like, in the same way, sort of like, and I keep saying sort of because this is an analogy, and the way we give more potential energy to an object by increasing its height, we're giving more potential energy to the charges by doing work separating them. Voltage is the amount of energy per Coulomb. Other than that, Ohm's law says V equals I times R, and I kind of gave you the ski hill analogy. Let me pause for a second. Alrighty. Number 1. If 2 amps of current flow through a light bulb for 20 minutes, A, how many coulombs of charge have flowed through the bulb? Okay, well, I know that current is defined as charge over time. So to get the Q by itself, that's going to be I times T. Q is it. So it's going to be 2 amps times, I don't do physics with minutes, so it's going to be 20 minutes times 60 seconds. I can probably do that in my head. I think that's going to be 2,400 coulombs. Is there a part B? Oh no, I must have deleted part B. Number 2 says find the current and the direction. Okay. So current, well, I know that V is 120. I know that the resistance is 20. We have V equals I times R. This is Ohm's law. So I equals V over R. It's going to be 120 divided by 20. This is going to be 6 amps. What direction? Well, current is defined as from positive to negative. So this is the positive symbol. So the direction would be this way. Now the electron flow would be in that direction, which would be counterclockwise. But because it's easier mathematically, and I'll convince you of that throughout this whole unit, it's easier to imagine the positives moving, then we're going to say the current is clockwise. By the way, the abbreviation for clockwise is capital C, capital W. The abbreviation for counterclockwise is CCW. You may see that in answer keys in the future, because I tend to abbreviate. Number 3. If this circuit is connected for 60 minutes, find the current and then the total charge. So this is what would allow you to estimate how long a battery would last. If you were an electrical engineer and you're designing a circuit, you know how much charge is stored in your battery. First, you would figure out the current, so you would know how fast it's going to bleed the charge off. And then you would be able to say, okay, on average, this battery will last for X number of hours before it burns out. A, current, well, that's going to be V over R. That's going to be 120 divided by 60. So this circuit is using up 2 amps. And then for part B, well, current is charge over time. So once again, we have Q is it. It's going to be 2 times 60 minutes times 60 seconds. So 60 times 60 is 3,600. I think this is going to end up using 7,200 coulombs of charge. Was I right? Woohoo! I was. Number 5, in a house circuit, oh, copy it first, Mr. Dueck. In a house circuit, take the voltage to be 120 volts. It's not exactly 120 volts, but it's close enough that we often use that as our benchmark. Find the current if we plug in a 240 ohm light bulb. So I think for all of these, we're going to be using I equals V over R. We start out with V equals I times R. So for A, it's going to be 120 divided by 240, which is 0.5 amps. For B, it's going to be 120 divided by 12, which is 10 amps. Hair dryers use a lot of current. Of course they do. They give off a lot of heat, which must mean they're using a lot of energy, and so they need a lot of charges bringing their energy through the system. C, a 20 ohm microwave, would be 120 divided by 20, which I'm pretty sure is 6.0 amps. And D, a 0.1 ohm wet finger, well, that would be 120 divided by 0.1, and that would be 1200 amps of current. Now, the reason the resistance is so low is because the finger is wet. If the finger was nice and dry, you have a pretty reasonably high resistance in your skin. It's why you can touch the ends of a battery and you don't get a shock going through your skin. Next one, number 6. Number 6, the circuit breakers in your house are designed to break the circuit if the current gets too large. Most circuit breakers are set to trip at 15 amps. There's a couple of exceptions, by the way. You probably have two 30 amp circuits in your house. One is behind your stove, because your stove has a special plug. It actually takes 240 volts, not 120, because it needs to move way more heat, if you have an electric stove anyways. And the other one is your dryer. If you look behind your dryer, you'll see the cord running to the plug is a big thick cord, and the plug is this unusual shaped one. That one is also taking 30 amps and 240 volts. Nerd trivia. If the house is 120 volts, what's the minimum resistance of an appliance? So let's see. I know that V equals I times R. I know that R then must equal V over I. We have 120 volts. The maximum we can handle is 15 ohms before it will trip. So 120 divided by 15, pretty sure that is, oh, I got the answer right there, 8.0 ohms. I think I said 15 ohms earlier. 15 amps is what I meant to say. So the maximum a circuit in a standard household circuit can handle is 15 amps before it will trip the breaker and automatically shut things down. Before we had circuit breakers, if you live in an older house, you might, instead of a breaker box, you might have a fuse box. And in the fuse box, rather than having a switch the electricity off, you actually melted a wire inside the fuse, and that would break the connection, but you'd also have to replace the fuse. Why is it important to have circuit breakers or fuses in the circuits of our houses? Explain using relevant principles of physics. So if the current gets too big, what that really means is, well, large current equals large number of coulombs per second, and that equals lots of heat generated inside the wire. And I think we can safely say that fire equals bad. So if you have too much current flowing through a wire, now you can design wires that can handle more current. The thicker, the larger a wire is, in the same way that the larger a school hallway is, the more students it can handle without them bumping into each other. The larger a wire is, the more current it can handle without generating a lot of friction, without heating up. Unfortunately, that also means that wire is more expensive. So for houses, we design our wires to handle 15 amps. Number 8. How is electron flow different from conventional current? That's a great question. So, electron flow, that's defined as from negative to positive, and that's what's really happening. Now, by the way, there is some controversy about this. For example, in Alberta, our province next door, they do not teach conventional current. They teach everything with electron flow. The problem is it's much more mathematically convenient to think that conventional current, or just plain old current, can't even spell it, conventional current, or just plain current, that's from positive to negative. In real life, charges don't flow from positive to negative, but mathematically, an electron moving one space to the right is the same as a proton moving one space to the left, because they both have the same magnitude of charge. You might recall from last unit, 1.6 times 10 to the negative 19 coulombs. We did look at that in that first lesson. So they both have the same charge. Number 9. Oh, can I get this all on one page? I'll have to shrink it a little bit. Dunk. There we go. Alrighty. This is one of those chart questions. I'm not going to read across. I'm going to read down. So, which of the following correctly labels arrows 1? So, arrow 1 is going from positive to negative. Arrow 1 is current. So no, no, yes, yes. I already know A and B are wrong. Arrow 2 is electron flow. That didn't help at all. Oh, but I know that this, the long line, is the positive. The short line is the negative. So X is positive, not negative. It's positive, not negative. And so the correct answer has to be C. I'm also going to be, along with this solution key, emailing out another optional Whoa Wednesday assignment. You can use that to replace any missing assignment. I'm doing that because some of you have told me that you can't access your old assignments, or you don't have a printer at home, or you don't have the equipment, or you don't have your binder handy, and so you can't necessarily look up the notes from last time. I recognize that. This is a really, really weird time. I'm also doing it because I'm a science nerd, and I'm trying to let you find some good YouTube science-based channels that maybe will bring that sense of, dude, Mr. Dueck, you just blew my mind a little bit. Okay? Hope you're all doing well, and take care. I should double check. That was the last question, right? Yeah, it was.